very good morning to all of you. It's great to be here. And today we are going to present this, our favorite topic of ours, next generation access networks. And, the way we have structured this presentation is essentially it's divided in three parts. First, we will evaluate, what is this next generation access networks that we all are aiming for? What are the value drivers for it? And then we'll, discuss around the importance of driving a legacy to the next generation path, and how does the importance of interoperability plays out, and the importance of standard to establish it. That's the part my colleague Simon Fisher is going to cover, and then we'll end up it will sort of conclude the presentations with the collaboration work that BT and STL are taking up in the Broadband Forum. That's how the overall structure is going to look like. Now, if we talk about the value drivers per se, what essentially is some of the ambitions that the technologists around the world are envisioning today in terms of this next generation access network, how it is going to benefit, in the world that is going to be, willing to develop things that haven't been there so far. And when you talk about those value drivers, what comes, as one of the salient point is this, notion towards open architecture. So essentially, you can think this way that there is a, access network implementation. There is a fiber grid that we have today in our, last mile implementations. And, if there are ways to deploy sort of software-defined open control and management plane capabilities on top of that last mile wireline access implementation, and if that open interface of those control and management plane functionalities are, something that can be leveraged to develop applications that would be of choice of the subscribers, choice of operators, choice of all the ecosystem vendors who wants to benefit from this underlying network implementation. And that essentially, is going to be the foundation for the next generation access implementations. How this overall architecture is getting envisioned? It's all built from the principles of having interfaces opened up for consumptions as a sort of a service model implementation. How you can develop your applications on top of those open interfaces. How we can leverage the underlying implementations to create a software as a service model implementation of your own for all your B2C, B2B customers. That's the kind of a target. That's a kind of a direction that some of these open networking initiatives are taking, specifically in the context of access network. So while this being one of the important aspect to look ahead and evaluate whether it is something that is achievable in the context of this next generation technology evolution, there are other salient points as well. One of the other points that we see getting discussed quite often is the ability to develop service orientation within this, access networking infrastructure. In fact, this is something which the concept that is shown here is one of the concepts that was quite, it was something that was initiated in the Open Networking Foundation, and then it was something that was accepted and acknowledged in various other forums as well. And in this particular direction towards service orientation, people have considered to take the benefits of economies of scale that is usually there in a data center network infrastructure, and then, to blend it with the agility of the cloud provider's environment, and then develop this new architecture of access implementation where you can roll this out as access as a service. That access infrastructure itself could become the service that you can offer to your ecosystem partners, to your developers, and to your end consumers. Now, of course, there are multiple technology blocks that comes together to deliver this, and cloud, SDN, NFV, all these are different technologies, different parts and parcels of this foundations that needs to be created for this. And last but not the least, if we are talking about those value drivers in the context of open networking initiative, in the context of service orientation, one of the other extremely important value drivers that comes on, on the charter of this next generation access network is to have the agility and flexibility inbuilt into this new paradigm. And here is a sample of what can be achieved out of that agility and flexibility. And this is just one example. There could be many other examples, but just to demonstrate the point of what is meant by agility and flexibility in an access network infrastructure, we're taking this, case in point of creating a multi-tenant access network infrastructure. Now, traditionally, there have been multi-tenant access networking infrastructure, which is, implemented today. But then the approach of those implementations, the way the fiber unbundling have been done, the way the different unbundling principles have to be adopted, the way the designs are developed to have things in a very fixed and in a manner that is very that's applied on design and not as dynamic as it could be. Now, this is where we are trying to show a particular implementation where something like programmable virtual unbundling that can be achieved out of a agile and flexible access network infrastructure. That multi-tenancy, or let's say slicing of access network implementation, could be done dynamically, could be done programmatically, could be done as on need basis. And if that agility and flexibility is inbuilt into the infrastructure, if it is backed up by software-defined implementations, if it is backed up by cloud-native implementations, then there are ways to create these dynamic slices of access implementations, dedicating these slices to the end network consumers based on the kind of services that operators would like to offer in case-by-case basis. Now, these are some examples of the value drivers that is leading us to this new definition of access network infrastructure. And but the question remains, how much of it is realizable? How much of it is actually connected to the real challenges that we are often encountering on the ground? And that's where I would request my colleague, Simon Fisher, to take over and explain some of these legacy to next generation challenges.
Okay, thank you, Saurabh, and good morning, everybody. Yes, I thought extremely good introduction into a topic which is a frenzied area of discussion within the networks industry currently, incredibly exciting. And I thought I'd spend the next 10 minutes just highlighting the network operators world and look at SDN through their eyes and the opportunities and challenges it presents. So just to set the context, the access network provides, as this slide shows, a service connection from the exchange building to all residential and business customers within its catchment, and also other non-served premise applications for telemetry and even mobile network operators, macro towers and small cells. So it uses a wide range of different transmission technologies to address the challenges that it sees in the geographies that in its catchment. Here you can see we're using FTTC, fibre to the cabinet, based on VDSL and GFast technology. There's fibre to the premises. There's SHEs or subtended head-ins, which we use to reach extreme distances to customers, say over 40, 50 kilometres away, and point-to-point fibre for providing carrier class services to enterprise and mobile networks. And at the exchange is really the area we're looking at here. We've got the layer 2 switch, which handles the aggregation of all of that customer traffic and the policing and management of that traffic, and handing over to the various service providers. The network operators around the world then fall into two distinct business models. There's the vertically integrated operators who control both the services that the customers get and the physical infrastructure itself. Or in the case of BT and Openreach in the UK, they work for an open access model, which basically Openreach provides the access transport only, and provides that to, I think it's now over 600 service providers who can connect in on the left-hand side of that layer 2 switch on this diagram to use that physical network to access any customers in that exchange catchment. Importantly, though, this diagram highlights the use of the traditional chassis-based layer 2 switch in the sort of top left-hand corner of that exchange. And the operator will have a number of suppliers who provide those chassis, which were supporting the various transmission technologies. But it also shows in the bottom left-hand corner of that exchange the move to a more disaggregated hardware and software model. But I think I want you to take from this is the vast majority of the operator's investment at this point will be in chassis-based hardware, and the move to that disaggregated leaf spine leaf type architecture we're seeing in the bottom left there is a fairly recent thing, and it presents to the access network operator a complex journey of migration. I think the industry can see there's a general trend towards SDN, and we'll go through the benefits in a moment. But realistically, as I always say to colleagues, this is like changing the wings of an aircraft while it's in flight. This is a complex journey of migration, and realistically, it's going to be measured in years, not months. So if we just move on, why are we looking to introduce SDN at all, software-defined networks? Well, on the right side of this slide, you'll see the current model and the evolution that we're trying to do towards the disaggregated model. The current solution requires the operator to buy OLT hardware and element managers that are bespoke to each of the suppliers it chooses to buy off. Clearly, these systems adhere to certain standards, but ultimately the operator will have significant cost and time to develop its OSS for every operational support systems for every single supplier it chooses to go with, and as in life, the various functions and services that it wants to introduce during that period. The benefits of the disaggregated solution are that the data and control elements are separated, and that enables the use of commodity hardware and open standard software. And as such, they can reduce the network build capex by having access to a wider supplier base and a general trend towards commodity-based hardware. The decoupling of the hardware and software also enables the leaf spine leaf architecture, which I referred to in the previous slide. And that, when you get into the world of plan and build of access networks, allows a much more efficient evolution of bandwidth or scaling of the bandwidth and the physical capacity of the network. The new SDN model should also reduce cycle times for introducing new generation hardware and new products. And the SDN layer promises a greatly reduced level of complexity of OSS changes. And once the network's built, well, for me, there's this incredibly exciting world of automation and streaming telemetry and the opportunity to reduce operational costs. Fiber networks will be radically different to the old copper networks that operators have known. They have completely different fault mechanisms and characteristics. And I think all operators are experiencing and expected that the fiber networks would be much, much more reliable. And indeed, they are proving to be so. So the focus on automation for operational tools and diagnostic costs is absolutely key once these networks are built to reducing the total cost of ownership. Okay, so this is a lovely world of SDN, but what are the challenges that the operators face to get there? So the current network operators will use a multitude of suppliers, as I've highlighted, to build their access networks, all of which are bespoke with minimal interoperability. A big problem for network operators. Clearly, these are designed in line, the various suppliers' equipment are designed in line with defined standards for the interfaces between network elements, but typically suppliers will have included additional features which result in operators just not being able to achieve interoperability between different suppliers' equipment. For example, if we plugged in supplier A's customer ONT, optical network termination, into supplier B's OLT layer 2 switch head end, it may work to a certain level of basic functionality, but it certainly would not offer the full range of functions. But there certainly wouldn't be interoperability between different suppliers' element managers and different suppliers' OLTs. This new architecture, SDN architecture, will offer a single software-defined network orchestration layer that effectively removes the need for multiple bespoke element managers, and therefore removes the need for OSS, operational support systems, to have any knowledge of the hardware components and transmission technologies that lie beneath them. Of course, that orchestration layer also needs to be made up of software functions that can be swapped out as easily as the hardware in order to avoid or swap hardware supplier lock-in for software supplier lock-in. The success and speed of the adoption of the SDN architecture and the orchestrator is critically dependent on standardized open interfaces. And those open standard interfaces are needed to create those southbound interfaces into the new legacy hardware, and the northbound interfaces to simplify the OSS and enable, as Saurabh has alluded to, the intent-based service management and automated operational functions. So what's the ideal architecture then? So we've highlighted that network operators need the flexibility to introduce and manage multiple vendor networks in a world where they need to continually evolve transmission technologies to meet increasing customer demand for service bandwidth and performance. Their key focus, operators, is flexibility and a continual drive to lower cost of ownership of their networks. The rate at which the new SDN solution can be adopted and the level of benefits it can deliver depend on its ability to manage not only the new disaggregated commodity hardware, but more importantly, the mass investment that operators have got in legacy hardware, which will need to be maintained for many years to come. So this slide highlights the general functional elements and interfaces that the software-defined access network orchestrator needs to offer. In the middle, we can see the software-defined controller, and below it, the functions needed to control both the new NetCoff-Yang native devices using open standard southbound interfaces, plus the vendor-specific adapters needed for legacy network elements and element management systems. And above that SDN controller, we can see the orchestration and management functions and the open northbound interfaces that allow much simpler OSS that uses standard APIs for service definition and intent-based service provision. So to summarize, network operators can see the benefits of software-defined access network architecture and are working with suppliers and organizations such as the Broadband Forum to define the open standard interfaces to achieve the required modular hardware and software components and carrier class performance that's required. However, realistically, the speed of that adoption to an SDN network by network operators and the level of benefits that can be banked is likely to be gradual and at a pace determined by the need to exploit the legacy equipment platform and typical network and technology investment cycles, which are realistically anywhere between 7 and 12 years. But inevitably the industry is trending towards disaggregated and software-defined networks purely because of the capital and operational benefits they can deliver. Reduced hardware costs, simplified cross-platform OSS, faster introduction of new services, and the smooth evolution of technology, and also that exciting world of closed loop automation for reducing operational costs. And with that, I think I'll hand back to Saurabh at this point.
Thank you. So, so as Simon mentioned, we already have realized the importance of establishing the interoperability, establishing sort of standard mechanisms which needs to be uh, developed, standardized in stable model. I mean, Broadband Forum is exceptionally, broadband forums, uh, coverage over the access network implementations is foundational, and this is where we started having this collaboration. Uh, the the bigger, um, the first set of implementations that we took up for carrying it to the standard body is the challenge of developing an automation capability around the telemetry information. So there are these network devices, and you are having this collection mechanisms today. You do collect the raw data, but then the ability to process this raw data, the ability to model your applications, to have your own mechanisms of developing the automation that you'd like to roll out in your production network, is the implementation that is that we have been focusing on today in the course of this collaboration that we were doing in the broadband forum. So while we were working towards this, what we realized is that there is this implementation, a reference architecture that come from broadband forum, which is focused on automated intelligence management, WT436. And then there is this working test that is evolving into defining the disaggregated architecture for this OLTU on implementation, which is working test text 477. And what we realized is that the telemetry information that is usually required from these disaggregated OLT reference implementations, which can be taken to the level of implementing an automated intelligence management framework, is something that is really important to get standardized, because essentially while we are working towards developing this new architecture, and while we are also having this legacy implementations today running in our existing networks, the automation capability can even start from this legacy implementation and can migrate towards this new implementation of disaggregated architecture. So this is where we got the collaboration started. We developed this proposal, which there are a lot of subject matter experts from BT who were present, who were working along with the folks from STL, and this is a presentation that we made to Broadband Forum a couple of months back, and then gradually this got discussed and debated in the community, and eventually this is something that is now been considered as part of this WT477 implementations. So we are progressing to develop all these newer standards which will be benefiting this new implementations, while keeping this link with the legacy implementation intact, while providing a migration path which is going to be seamless. And that's where the focus is today, and that's how we are collaborating to make this effort to standardize it. So this architecture is showing that implementation. If you take a look at this diagram, there is this DULT, which is a disaggregated ULT, which is a subject matter of WT477. And then there is this access SDN and MNC, management and control plane layer, which is essentially providing the management and control plane functionalities built on top of this disaggregated architecture. And then you see this collection framework, the pre-processing modeling framework, and the interfaces. The interfaces that you're seeing here, half of it coming from 477, half of it coming from 436. And this integrated architecture is letting us open up this telemetry transport capability, letting us open up this telemetry transport for developing further automation applications on top, for closed loop automations, for open loop automations, for various different types of implementations that can be taken to this last mile network. Now, this is where there's quite a bit of um, you know differentiated offering that we are trying to bring to the table in terms of the standardization effort that is getting worked out in the broadband forum community. This is where we stand today, and it's still a long way to go, but there is quite a bit of effort that is maturing towards this new paradigm, towards this next generation of access network. And as we progress, we are pretty sure the value drivers that we've kept as our ambitions will be actualized with this effort to make it seamlessly integrable in the legacy implementation, seamlessly upgradable to this modernized architecture. Well, that's where we stand today, and this is what we want to cover. I'll hand it over to my colleague Jim now. Jim, over to you.